So, ja, ein herzliches Willkommen, einen schönen guten Morgen zu unserem nächsten Webinar von unserer Webinarserie von der Firma syscomtec. Mein Name ist Manuel Grimmer. Ich bin in der Position von der Vertriebsleitung bei der Firma. Also wenn Sie Fragen haben während des Meetings bzw. danach, gerne jederzeit an mich bzw. an uns richten. Einige Infos zum Webinar. Es wird auf Englisch gehalten von unserem Premium-Partner CYP. Wenn es Fragen gibt, darf jederzeit während dem Webinar gefragt werden, beziehungsweise überwachen wir auch die Chat-Funktion und beantworten hier Fragen, beziehungsweise schreiben Sie die Fragen in den Chat rein und dann wird es einfach im Meeting direkt besprochen. Also wie gesagt, jederzeit ist die Interaktivität von den Besuchern erwünscht. Und ich würde sagen, dass wir keine Zeit verlieren und die wichtigen Informationen nicht vorgehalten werden, würden wir jetzt starten. Also nochmal ein herzliches Willkommen zu unserem HDMI 2.0 Webinar über das IP-Übertragungssystem von CYP mit dem neuen SDVoE-Standard, wo man ein 10 Gigabit Netzwerk benötigt. Und ich darf jetzt das Wort übergeben an unseren Lieferanten CYP. So, Dan, ja, deine Worte.
Wonderful. Thank you, Manuel. I caught most of that. Ask Manuel questions. Put questions in the chat. Very good. I agree. Perfect. Good morning, everyone. Thank you for joining us. My name is Dan from CYP. I'm a key account manager. With me is Kevin Cray. I'll let you introduce your title, Kev.
Good morning, everybody. I'm Kevin Cray. I'm Technical Product Development Director here at CYP.
Wonderful. So as Manuel said, today we'll be looking at AV over IP with SDVoE over a 10 gig network. And let's get on with the presentation. Here we go. So as you probably know, CYP are known for signal distribution and signal management, covering, as you see on screen here, AV over IP, matrices, we have extender products, audio products, converters, testing products, a very wide range, and those can be used across Pro AV, residential, Heimkino, also industrial and medical use. So lots of use for these sorts of products. And today, of course, we'll be looking at 10 gig AV over IP. So we'll start off, we'll have a quick look at our 1 gig system to see where our AV over IP range starts, and then we'll move on to the 10 gig SDVoE system. So looking at AV over IP in general, of course, it can send video, audio, power over Ethernet, control signals, and also USB functionality over a single CAT cable up to 100 meters, all using a 1 gig network switch. So in our 1 gig series, that's the IP CS7 controller, the IP 7000 TX transmitter, and the IP 7000 RX receiver, again, all through a 1 gig network switch. This sort of system gives you flexibility as you can grow the system at any time, add more transmitters, add more receivers, and grow that system in size. The CS7 controller has a very nice drag and drop interface, very simple to use. The system has its own setup wizard, so it can help the installer to configure the system if they're new to the system. So very simple to install. And this sort of product can work as a matrix, point-to-point distribution, video walls, groups of screens, and also has separate user logins for different zones. And because it's all on a 1 gig network, it's very cost effective. So you might think, why would we need SDVoE? Why do we need 10 gig? Carry on.
Dan, sorry
No problem.
für die Unterbrechung. Ich muss jetzt kurz einhaken. Also wenn unsere Kunden gerne mal dieses IP 7000 System mal anschauen wollen bzw. testen wollen, wir haben dazu ein fertiges Flight Case generiert, ein Demosystem, bestehend eben aus 2 Sendern, einen Netzwerkswitch natürlich und 4 Empfängern, dass wir auch eine 2x2 Videowand generieren können. Natürlich ist auch eine Standard-Videoquelle integriert, was ein Bright Media Player ist. Zusätzlich kann bei den zweiten Sendern noch ein normaler PC angesteckt werden. Und passend zur Steuerung wird ein kleines 10 Zoll Display mitgeliefert, wo wir einfach diese Web-Oberfläche direkt sehen, wo wir da eben diese Umschaltung machen können, sage ich jetzt mal, beziehungsweise vorgefertigte Presets einfach ansteuern können, sage ich mal. Also wenn es hier irgendwie Interesse gibt, einfach bei uns melden, dann können wir da gerne was organisieren. So, sorry Dan for the break.
No problem. No, good point.
Good.
Yeah, it's great to have that demo system. Yeah, very, very useful. Good stuff. So yes, excuse me. With that 1 gig system, we might then think, why would we need SDVoE? Why do we need 10 gig? So let's look at that now. Obviously, 10 gig network, you have higher bandwidth available. So you can pass more data through the system. So this will then handle formats like 4K HDR, 4K 30 uncompressed, or 4K 60 444 as well, with some light compression. This system has incredibly low latency. So it's a very low latency system, which is brilliant. Ultra fast switching as well. So we'll talk about that as we go through, but switching from source to source is incredibly fast. It has a really nice multi-view system, which again, we'll look at shortly. And there are fiber options available with our SDVoE system, and that has all the normal benefits of fiber, like obviously the no electromagnetic interference, and also the option for longer transmission distances. So let's have a look at the SDVoE 10 gig hardware. This is a quick comparison. The left-hand side is the 1 gigabyte system we started talking about versus 10 gig SDVoE. So as you can see, the main difference is really the higher bandwidth available, lower latency, and the ability to pass higher resolution and higher timing formats. If we look at the products themselves, we have a CAT transceiver. So this is a transmitter or receiver running with traditional CAT cable. And then on the right-hand side, you have the fiber version. So again, transmitter or receiver, it's a transceiver, and this model runs on fiber. If we look at the CAT model first, you'll notice that this model has HDMI in and HDMI out, obviously because it's a transmitter or a receiver.
Those extra inputs or outputs, depending on which way around you have the transceiver, are still useful. When your transceiver is in transmitter mode, the output becomes a local bypass output, and when in receiver mode, the input becomes a localized input for switching an individual RX to a local source. So they still have a use even when they're in the opposite mode to the actual HDMI connection.
Wonderful. Yeah, thank you, Kev. Great point. So with these CAT models, you can transmit up to 100 meters either side of the network switch. And as we said, these can be configured as a transmitter or receiver. As you move up to the fiber models, you'll notice that you then get a DisplayPort input as well. So an extra DisplayPort input. These models can transmit up to 300 meters with the supplied fiber module and using OM3 fiber cable. Let me just quickly admit somebody to the session. Won't be a second. There we go. If you change the fiber cable to OM4, you can then get up to 550 meters with OM4 fiber cable. And if you actually change the fiber module for a third-party fiber module, you can get transmission distances up to 10 kilometers in single mode. Any other points you wanted to add on this model, Kev?
Yeah, there's even ones that go longer than that. That are available. You just have to be really careful. You can go sort of 20-30 meters on some of them, depending on the exact fiber module and of course the exact fiber cable you're using. Obviously the units become supplied with our standard SPF plus module already installed in the unit, so you don't need to get one, they're already there, and that's for the standard 300 to 550 on the standard OM3, OM4 cabling.
Fantastic. And same thing as you said earlier, Kev, then the HDMI inputs and outputs are always working, even in transmitter mode or receiver mode. Yeah, perfect.
Yeah, there is some nice, interesting development from SDVoE as well, from SDVoE Alliance and CYP, the chip manufacturer. Where we're working on a chip, on an IC, and new development with that chip, where you can produce a transceiver that can actually transmit and receive at the same time. So that's going to be a very interesting development through the latter part of this year, and to be released early next year with any luck. That development's still at the moment, but it helps you to understand that the SDVoE system is still evolving and still developing. Up to this point, they use FP chips, which is a programmable chip. Now they are going over to their own bespoke IC silicon they've made themselves. So this is a process of evolution from SDVoE. And whilst the system has been around for a good few years now and is very solid, they are still developing really interesting products and ICs for this range.
Wonderful. Yeah, thank you, Kev. If we look now as well, then of course all of these systems, we have a controller as well. So we have our SDV CS8. For simple control of systems, you can, for example, connect the CS8 directly to a touchscreen display with HDMI and USB, and then that will give you the touchscreen functionality with our drag and drop system. You could connect this to just a local monitor as well, and then use keyboard and mouse. Again, that's absolutely fine. We have options like our CRTG1 trigger pad as well, which can be directly connected to our controller, and these buttons could then activate some of the presets that you may have built in to the unit. So really simple. Or of course, you can control this system from, well, you can trigger elements, can't you, Kev, with third party, but you still need the controller on the system.
Oh, absolutely, yes. With the SDVoE system, unlike other AV over IP systems, you don't need to do anything to the network switch. The network switch requires no configuration, no IT skills at all. You literally just turn it on. But the upshot of this is that any SDVoE system that is actually going across network infrastructure does need the SDV CS8 to be in the system, because the SDV CS8 runs a virtual server that does all the communication and all the configuration of the network switch involved in the system. So if you're just going point to point without going through a network, yep, you can just do a point to point with SDVoE like you could with HD-Base-T. But to build a bigger system across a network, you must have the SDV CS8 in the system, or it will just not work.
Wonderful. Thank you, Kev. Superb. So if we have
you
a
can
look
actually
now,
have multiple ones in there as well. I mean, if you want to have, you know, if you want one large system and you want to break it down into little subsections, you can have more than one SDV CS8 in the system, so you can have little subsystems of a wider, larger system as well.
that's learning for me as well. Good stuff. Didn't know that one. I'll let you move on to this part, Kev, with transmitter mode and streams and things like that.
Yeah, please. Yeah. So obviously, what you're getting is a whole bunch of different streams that come across the network infrastructure. So you've got the primary video stream. So this is your primary full screen video screen. So as Dan's already mentioned, if you're going up to 4K 30, 444 8-bit, there's actually no compression at all on the system. So it's only when you go above the 9 gigabits per second, which is classically HDMI 1.4 specification, that actually you have a compression. But then the compression is quite light. I've got 1 to 1.3 in my head, but it's definitely 1 to 1 point something is the compression. So the compression is incredibly small. If you think about compression that we used with HD-Base-T, either whether it's VLC or DSC, this is like a compression of 1 to 7. So the compression on SDVoE on this primary stream, even when it's 4K 6444, is incredibly light and is a bespoke compression designed by the SDVoE Alliance themselves. So the primary stream, this is your primary video stream up to the 4K 60. And then every single TX creates a secondary substream, the multi-view stream. So the resolution and the timing, the exact timing of this multi-view stream is dependent on how you set up your multi-view and where you've cut things up and what size it is. But this is a completely independent stream, which is why you have this great level of versatility with the SDVoE system that you frankly don't have with any other AV over IP system. So within that, the video wall stream, it feels like it's a separate stream, but actually it's not. Actually, what happens there is the receiver receives the primary stream and then uses the scaler in the receiver to chop out the section of the image that you might want and scale it back up. So it's actually derived from the primary video stream. And then you have the audio stream, so your classic HDMI audio, analog audio. Then you have USB, IR, and RS-232. Some SDVoE have got large bits of USB on them. Some of them don't have any, so sort of cost reduction. Then you've got ones that have got like a small amount, and then you've got ones with bigger hubs on them with 2 or 3 USB ports on them. And as I say, development is happening across the SDVoE system all the time now. So this gives you a nice little example here of how these streams work. They all come into the network switch and they all just come straight out there. So what we're showing you there is just the primary stream and the HDMI audio stream that allows you to grab those streams. Obviously, it's a multicasting system. So all of these streams are always present inside the memory, if you like, of the 10 gig switch. So whether they're being used by any receiver or not, that all of that data is always held in the 10 gig switch live, and it can just be recalled at any second. So you just pull down the relevant streams you wish to use. And this can all be managed through the CS8 very, very easily. The CS8 has its web GUI, it has an HDMI output and a USB output, so you can very easily connect it to a touch screen. We use those very often, but also that web GUI is available from any computer that's connected to that network as well. Can't hear, Dan.
That's when I press the mute button. Thank you, Kev. Good reminder. Good reminder. I was just miming.
Yeah.
So another great feature then of the SDVoE system is this one we're going to talk about, multi-view. So essentially showing multiple transmitters on one receiver. So like a picture-in-picture style. So we'll show an example here with 4 transmitters all sending out their multi-view stream, which, as Kev said, they create their own multi-view stream. And in this example, this receiver is saying, I want transmitter 1, transmitter 2, transmitter 3, and transmitter 4 in a really simple quad view. But I'll let you talk about these, but we've got a few more, haven't we, as well, Kev?
Yeah, I mean, if you think about that simple one there, if your whole frame is 4K, then each sub is going to be 1080p. So at that point, the TX, no matter what the resolution of the incoming signal is, it will grab that signal and either downscale it and upscale it and send it separately across the multi-view stream, which then the receiver receives all 4 of them and just links them back together and pushes them out to your single display. So it's incredibly useful, incredibly flexible. You can have multiple multi-views, but you need to be careful how you arrange it, because you only have a multi-view stream. And so if you're using the same TX in multiple multi-views, can I say that? Multiple multi-views?
I think so. Yeah.
I think that's all right, multiple multi-views. Then you need to make sure that each section, if you're using the same TX on 2 different ones, that it's sending the same resolution to both multi-view streams. But there's lots of different multi-views available. I think is it 27, I think?
27
different multi-view arrangements that presently SDV have defaults for. We haven't yet come across anybody who requires a different one, but my understanding is that SDVoE Alliance are looking at that, and they're looking to have slightly more flexibility on how that is set, so you can kind of configure one yourself, which is great. This is another example of how SDVoE are continuing to evolve their system and their products.
Did somebody have a question? Not a question from my side, but ja, wir haben bei syscomtec in den letzten Monaten unterschiedliche Tests gefahren, was genau diese Multiviewer betrifft. Die klassische Anforderung ist natürlich, dass jetzt immer mehr Leute ganz große Displays im Konferenzraum haben oder eine LED-Wand, wie es wir im Hintergrund haben. Da haben wir eben ganz klar gesehen, dass diese 4K-Auflösung für eine Multiview-Anwendung extrem von Vorteil ist, beziehungsweise von der Qualität ist. Also wenn man einfach nur einen Multiviewer hat mit Full HD und teilen das eben in vier Teile, dann habe ich natürlich nur pro Teil 1/4 von der Full HD-Auflösung. Und da kommt genau diese 4K-Auflösung doch sehr zum Vorteil, dass man eben da die bestmögliche Qualität irgendwie erreicht. Also von denen her macht es natürlich Sinn, dass man diese Übertrager schon anpasst an die Maximalauflösung, was mein System irgendwie verarbeiten kann. Auch wenn der Anwender in der Regel nur klassische Full-HD-Quellen hat, was irgendwie Laptops sind oder ähnliches. Aber da sollte man einfach in der Planung schon bedenken, dass es einfach wirklich an der Bildqualität am Schluss sehr entscheidend ist, was das Übertragungssystem kann. Aber das ist nur eine kurze Info von unserer Seite. So Dan, go ahead, please.
No problem. Thank you. Thank you. So another thing, like we said, so these are some of the presets that you can select, and we'll show you how to add transmitters to it later. But just to remind as well then, these transmitters would be sending out their multi-view stream to this receiver, but these transmitters could also send their primary signal, their primary picture, to a totally separate receiver. They can be also sending out to video walls as well. So it's very, very versatile. You're not limited to just multi-view. This transmitter can be sending out multi-view to one receiver. It can be part of a matrix in another one, just showing on a single screen, or it could actually be then sending out its signal to be part of a video wall. So very, very versatile.
Absolutely.
Let's have a look at one of the SDVoE series case studies, which is showing this technology in action. So here we see the Zurich Opera, and they needed a system that could basically show the live video of the actors, the performers, on some big screens. But as you can see as well, they have some interesting screen layouts. They were using these with large screen projectors and needed a system to run it. So thanks to the low latency of SDVoE, that was one of the main reasons the system was chosen. They're obviously filming the actors, the performers live, but that needs to be shown on the screens in the background with no delay, so there's no audio sync issues. So again, the low latency of SDVoE really gave itself to this system. So that's a key factor of this with the low latency. And if we look at how this system was running as well, a whole series of transmitters, all running into a 10 gig network switch, with the controller on top of that as well. And this is where it gets really interesting. So one receiver here is then being used as part of a matrix, just showing a single screen. Another receiver then running multiple transmitters in a multi-view, in a picture-in-picture mode. You've then got another receiver showing 4 transmitters in a quad view mode. And then another 4 receivers running as a video wall. So again, that shows the flexibility of the SDVoE system. All of those transmitters being used in various ways across the whole selection of receivers. And again, all, as we've said, with the very low latency, and as we said here as well, the ability for the multi-view and picture-in-picture. So again, just very, very flexible in how you can build that system. So I'll hand you over to Kev to just run through some of the main features of the CS8 controller.
Thanks, Dan. So what we've got here is we've got the main web GUI from the CS8. As it says, that's available from any computer that's connected to the same network, and we'll talk about how we bridge network systems in a moment, as well as from the direct HDMI output from the CS8 as well. So within the monitor and control section here, you have a sub page that shows you every single stream that's going on, as plus video wall, multi-view, and macro recalling. So there you can see that within the video section, you have various different icons and screen grabs. So the transmitters will grab a screen and display refresh that screen every second or so. And then you also have some useful icons there that tell you information about the transmitters and receivers. And we've got that page in this now, haven't we, Dan?
We have. Let me just do this fancy graphic. Ready? Ooh.
And then,
there you go.
Yeah. And then you can just simply drag and drop your transmitter to any of the receivers, any groups, any multi-view, any video wall arrangement that is in your receiver groups. So obviously this can be done from the controller itself, from a web GUI, but obviously you can also just send tailnet commands to the CS8 in order to use third-party control systems. It's a simple set of commands. You tell it what you want to do, so you're not having to use that system. The web GUI, and that is brilliant for the configuration of the system, but it's totally easy to configure the system to use it with other third-party control systems. You're just simply sending in tailnet commands to the CS8, telling it what you want to do, rather than doing any physical dragging and dropping. So here we have a little breakdown of the icons. So obviously in certain setups you can't show the video. So normally a TX will show the video that's coming into the TX, and an RX will show the video that's coming in an RX. But when it's in a multi-view mode, you have multiple RXs, you have lots of TXs going into the RX, so you'll show this multi-view picture. And the same with video walls. A video wall is a group of RXs, so you can make a group, and we'll show you how to do that. And then on the monitor control page, it will show that 3x3 video wall picture. So then dropping down through the icons. So no signal. This tells you that the transmitter can be seen on the SDVoE network system, but it's not receiving a signal. So the source is not turned on, or if it's the fiber one, perhaps it's on the wrong input. Again, you can very easily adjust. And then not connected, this is the reverse. So this is for the RX, and this tells you that there isn't a screen at the other end. There's nothing connected to the other end. This might just be that the screen is completely off, or it might be that it has been disconnected somehow. So again, it's very useful for troubleshooting. Even for remote access. Obviously, if you remote in, if you leave a little PC there and you remote in, you can very simply say, look, that source has not been turned on, or it's been disconnected somehow. And the same with the screen. The support, This is just an image that comes up if you're using some kind of weird, well, not weird, maybe some kind of PC resolution where the receiver and transmitter aren't able to show you the thumbnail, the small video picture that refreshes every second. And then you have a triangle warning sign. So this is when the video and the multi-view streams are actually starting to go too close to the 10 gig bandwidth. So what happens there is obviously the transmitter can output it, but the 10 gig IO input and output of the physical network switch can only handle 10 gig. Again, we'll talk about this later because we've during the development of our system, we've put in some automated systems to protect you from this happening. And then you have the offline icon. So the offline icon is simply telling you that as far as your system is today, this transmitter or this receiver cannot be seen on the network. So someone's unplugged it or something has gone wrong. So again, very useful set of icons that just help you understand the system and what's happening in the system with a nice visual representation.
And just to confirm then, Kev, they would all come up on the transmitter or receiver side on this monitor and control page?
Absolutely.
Perfect, perfect.
So if we have a quick look at the system. So the first thing to note here is all of our IP controllers, actually, no matter what system they're in, all have 2 LANs. So the idea of this is relatively straightforward. The LAN 1 is the LAN that is, it's the PoE LAN, so it gets the power from the network switch, and B, it's the design to be connected to your main SDVoE network switch. So because SDVoE does use a lot of bandwidth, it is normally considered pretty normal for that 10 gig network switch to be only being used for SDVoE. If you have a smaller system, you could set up VLANs and use it for normal network traffic as well. But normally, you're only using that 10 gig network switch for the SDVoE system. So you need to be able to bridge from your normal network traffic and system to your SDVoE network infrastructure and traffic. So that's where the second LAN comes in. So the second LAN is to be connected to your normal IP network infrastructure. And so then you can access from your normal network, you can access everything through the SDVoE system, and you can access everything on the CS8 without having to ever go into the actual SDVoE network infrastructure. So the CS8, like all our controllers, acts as a bridge between your AV over IP network infrastructure and your normal network infrastructure. And so it allows you to keep the two separate but joined.
Perfect.
So look at the system settings. So you've got normal things: log out, change of password, saving configs and uploading configs, and saving a log. Now the log is more for technical support. So if you are building a system, you seem to be having a problem. If it's not something we can solve straight away, which most of the time it is, we might ask you to download the log and send it to us. You won't be able to look at it, but we will. And it tells us how your system is configured and what recently has happened in the system. So it's quite useful from a support point of view. And then you've got a classic reset. So you've got a factory reset of the CS8 itself, and then a factory reset of all the transmitters and all the receivers in your system. It also tells you the serial number there of the CS8 you are physically using. And then you've got firmware updating. So again, you've got the ability to upgrade the CS8 itself, the controller, or upgrade all transmitters and all receivers. And it obviously tells you the details of the configuration and the firmware in use there. So the idea here is even if you've got mixed controllers, say that you've had a system installed for a while and you want to add some extra transmitters, and you want to add some extra receivers, and maybe there's been a new firmware release since then. You don't have to worry about which transmitters are the old ones and which are the new ones. You just load the firmware into the CSA, hit upgrade all, and it will check every single TX if that's what you're doing, and check which firmware it's on. And if it's not on the latest firmware that you've uploaded, it will upload it to it and reset it for you, and just power cycle it when it's finished, so it comes back refreshed and on the latest firmware.
Wonderful.
So the settings. So this is where we can make groups and macros, and we can also look at the RS-232 IR, the trigger for the physical trigger, and EDID settings. So this is a very and all settings kind of work this way on the SDV CS8 system. So if you want, for example, in the group here, you want to create a new group, you simply hit the plus button. This will bring up a new group in the names below you, and then you can decide on its order, where do you want to see it in the list, decide what it's doing and what name is it. So what it's doing, is it doing video, is it doing audio, is it actually an IR RS-232 or something else. So you can just decide primarily what you do, and then you can just add devices to that group. And it's very similar with the macros as well. The RS-232 and IR, this allows you to configure the RS-232 and the IR, and the EDID is classic EDID management, so you can decide for every TX whether you want to use the EDID that's coming from an RX and thus a screen, or whether you would like to use some of the built-in EDID presets that we provide you with. So overall, it's a very simple and visually active system that allows you to configure it very, very well. So in this system, we have different pages for the transmitters and the receivers, and it has a whole host of information. We'll try and go through it as well as we can. So first of all, here you have this hello function, which some of you may know if you've used any of our AV over IP equipment before. So this hello function is the ability to turn this on and have the transmitters or the receivers in the receiver have the LEDs on the front flash at you. So this is it's a very simple idea, but it's very, very effective. It allows you to identify, so you've labeled your transmitter media player 2, and you want to know which one it is. You might have a rack of 10 of them. Which one is it? So you just turn the hello in, and then you know you're connecting it to media player 2. So just literally slide it across. You have a little icon reference there as well, and you have an ordering. This is the order which these transmitters appear in the monitor and control section. So then you have some text, basically just telling you the name and the IP address. You can't edit it here. You edit it in the device settings later on, which I will show you, but it just gives you a quick visual of what the transmitter's called. So normally you would call the transmitter based on the source that's going into it, and the IP address for reference. Of course, we can see there that all those IP addresses are 169.254. So what happens here is, because we're telling you you don't need to make any setting changes to the 10 gig network switch, you may not have configured it as a DHCP server. You don't need to. All of SDVoE equipment has the ability to use the auto IP method of assigning an IP address. So this will automatically assign an IP address. And remember that the auto IP, the 196.254, is a network-wide predefined auto IP address. So it's not something bespoke to SDVoE or any other system. It's actually a network-based thing, and no DHCP server will ever assign anything in the network to a 169.254. It is completely reserved for auto IP. So you know, it doesn't matter how many units you have in the system, you never have to worry. They will auto IP their own address by themselves. And then we have our video network RS-232 device and USB info pages. So these are where we have various settings and various bits of information. So the video setting here, it shows you the all about the incoming video signal, or the RX would be the outgoing video signal. So it tells you the resolution, the color depth, the color space, whether HDCP is on, and your EDID information. Are you using EDID from one of the presets, as we have here, emulator, or are you using an EDID from one of the RXs and thus the screens on the other side of it? It's a nice piece of information. And then we have the network. So here you can actually make changes. So the first thing you see there is the MAC address. Obviously, that's unique to the unit. And then you have the IP modes. So in DHCP mode, if there isn't a DHCP server, this is when it will auto IP. So even if you leave it on DHCP and you haven't connected to a DHCP server, it will automatically drop over without you even have to make a change to auto IP and assign it an auto IP address. But you can actually there change it to static and assign your own IP addresses as you require. The RS-232, so this just tells you the common configuration of RS-232. Baud rate, data rate, everything like that. So very simple. I'm sure you're all used to seeing this. So here is the device settings. So this tells you version numbers. It tells you lots of information, and we'll go through this bit by bit because it's actually quite key. So the system command. So for example, when you receive transceivers, they are inherently in transmitter mode. So you buy them, they're defaulted to transmitter. So they will all appear in your transmitter list when you connect your CS8. So within the system command area, there is a function called transform. So when you hit this function, it will change a TX into an RX mode and vice versa. So it just allows you to transform the setting of any individual SDVoE product from a TX to an RX. Have we got a drop down of that, Dan?
Unfortunately not, I'm afraid. No, sorry.
Okay. So you have other system commands like reboot, reset, system reset, things like this. But it's the transform one that's really important, because obviously when you're manufacturing these, they're all set to the same thing to start with. So you need to use that transform function to change your TXs as they're out of the box into RXs as you need to use them. And then we have the name. So this is where you can just put the name of the transmitter. The default is always the MAC address, but obviously you're going to change this to what suits you in your installation. And then for the transmitters, you have audio port direction. So on SDVoE transmitters, you have an audio port, but it's not defined as an input or an output. You can decide, is it an input or is it an output? So if you need it to be an input to push some local analog stereo across the SDVoE network to something on the other side, you can. But also you can change it to an output. And what it does then is the incoming signal, say from the HDMI, as long as it's stereo, PCM stereo, then you can get that to de-embed straight out, which is incredibly useful if you have your amplifiers local to the transmitter area. And then you have, oh, typical, that always happens. I'll turn that off. And then so that's the audio one there. Thank you, Dan. And then you have HDCP support. So you've just got standard HDCP support and HDCP 2.2 support. So this last section, the divide frames per second by 2 mode, and the native divide and the multi-view divide frames per second. This is where we manage the bandwidth, because remember, we've got to ensure that we only output 10 gig, because the network switch can only handle 10 gig. So if you're actually, your primary stream is 4K 60 444, and you want to try and output a multi-view where the transmitter is also wanting to send 4K 60 444, even with the compression that are on there, this becomes too much bandwidth. So as a default, these units come with this divide the frames per second by 2 mode in auto. So what it will do is, as your transmitter starts to go over the 10 gigabits per second, it will look at the two video streams and it will say, right, I'm going to go over what the network switch can handle. So what I'm going to do is let's take the multi-view. I'm going to make the 4K 444 60 multi-view stream. I'm going to drop it to 4K 444 30, thus bringing the bandwidth within the 10 gig that needs to be under for the network switch. So this is in automatic. When it's the preset is automatic, so it will do it for you. You can actually turn this off and manage this yourself, and decide whether you want the native and the multi-view to be subdivided by 2. And then we have IR routing auto paired. So this allows you to pair the IR routing with multiple RXs or multiple TXs and set up that pairing. It's defaulted to always TX to the selected RX, but you can actually change this configuration and hard fix it as well.
Perfect.
And then for the USB, so where your transmitter has USB functionalities, this just shows you the different elements of the USB, because it's almost like a different little stream or a different IP address for the USB to keep the bandwidth high. So that's all relatively straightforward. The important bit there is the simultaneous mode. So in this simultaneous mode, you can enable this simultaneous mode, and you can allow the USB from the transmitter to be connected simultaneously to up to 7 RXs. So it's quite a clever way of allowing the USB to be from one source to multiple receivers at the other end. So if you've got one PC and you want to, say, switch it between different hot desks with different keyboards and mouses, you can.
Excellent.
So the receiver page is somewhat similar. You have the hello function, you have the icons, you have the order, you have your names, and you have your IP addresses. This is all the same. So the info pages are very similar as well. So your video info page, it just gives you the information on the video page. The network allows you to configure the network. The RS-232 and the USB are the same as what we've seen before. So where this slightly differs here is the device settings. So again, we have this system command. So even when you've changed, if you want to change something from an RX back to TX, you want to reboot the unit, you want to refresh it, you want to factory default it, you can do all those things there. But then we have a whole bunch of audio settings. So the idea here is that we don't always want to independently control the audio. That's just sometimes awkward, because you simply want the audio to follow the video. So here we have some very simple ways of just allowing that to happen. So you can set the audio source to always follow the video source. You can set it to follow in bypass, or you can set it to be independent, and then you switch to independent. And then the same for the analog audio. You have the ability for it to follow, but you also have the ability for it to downmix. So with the SDVoE system, if you're putting in multi-channel LPCM, not encoded, not Dolby DTS, but multi-channel LPCM, you can actually take that multi-channel LPCM and push it back together into stereo. And so that's really a useful function. So as long as you can get your source to decode Dolby Digital into its separate 5.1 channels, which, for example, most players can do, you can actually get that to downmix where you require it. And then the follow mode. So again, that's another way of just allowing you to have the video to follow. And then the analog audio follow mode. So again, you're just talking about it following it around. And then the IR routing auto pair. So this is just whether you're hard setting IR from one TX to one RX, or you're allowing it to move as you change TX to RX.
Excellent.
So now we have a look at the scaler page. So these things are very, very simple to operate. Again, it is a very simple drag and drop. So any groups and all RXs will always appear on this on the receiver page. So the scaling is based on the receiver. So if you want to hard set an RX to a screen, so it always outputs 4K 6444 because that's what the native pixels of the screen are, then you can do it here. You simply grab the RX and drag it to the relevant resolution that you wish to have. So this is also how we manage ultra fast switching within a system of switching. Obviously, we've discussed that the latency of SDVoE is incredibly small, and it really is absolutely tiny. The SDVoE system was designed for OR, for operating theatres, so for brain surgery and things like this. You imagine, you can't have very high latency if you're doing brain surgery. So it is incredibly small. But latency is not, that's the speed it gets to arrive. That's not its switching time. Obviously, fast latency helps your switching time. But one of the main factors, and this can often be forgotten about switching time, is the screen itself, is the display itself. If your display is native RGB 444 4K, when you throw RGB 444 4K at it, get a picture, great. If you then switch to a source that's 1080p 422 YUV, then the screen itself has to change all of its settings and then scale the image back up to 4K. So the screen will take 2 or 3 seconds to switch, at least. So if you enable the scaler on the SDVoE system, the TV, no matter what the incoming source is, the TV will always get 4K 60 444. So the TV doesn't even know, because of the incredibly low latency, the TV doesn't even know that you've switched the signal, because as far as it's concerned, the signal never stopped. And this is how you get ultra fast switching. Remember that you can't have HDR and ultra fast switching using scaling. As soon as you scale an HDR image, you're losing that high definition, high color bit rate. So you've got to make a choice. Do you want ultra fast switching, or do you want HDR? That is standard for everything. It doesn't matter what manufacturer of equipment you use anywhere in the world. A lot of manufacturers use this scaling trick in their receivers to enable ultra fast switching. So it's the same for everybody. If you want ultra fast switching, put the scaler on. If you want HDR, leave the scaler off. And then we have video wall and multi-view setups. So these are great. This is just such a great thing. You can go up to 8x8, I believe, in video wall. And basically, you can see in the middle there, you've got a section that says receiver. So this will list out all the receivers in your system, and you go up and down to see them all. So it will list out, if you have 64 receivers, you'll have all 64 receivers there. So now we have the same principle as when for all configuration in SDVoE system. If you want to make a new video wall, you hit the plus button, you decide its order, you name it, you give it a transmitter. Now, you can change the transmitter that's feeding the video wall at any point, but to configure the system, you need to tell it what is your base level transmitter, which is the one you're using. And then you decide the display resolution and the aspect ratio. The number of screens in the wall, is it a 2x2, 3x3, 8x8? And then you've got bezel correction there as well. So let's say this is we've got an 8x8 in front of us. So inside the receiver section, it will list all of your receivers. So you've then named a group of receivers, video wall 1 to 64. You simply pick up video wall 1 and drop it to TV 1. And then do it for 2, 3, 4, 5, 6, 7, and you just continually drop them, and you simply just drop them into the right place on the video wall. hit execute, then you can look at the video wall and make sure it's working, and then hit save. And then you've saved that video wall, and after you've hit save, it will now appear in the monitor and control section and is available via telnet commands to change as well. So all of the SDVoE configuration for this type of thing is very, very similar. So if we look at the multi-view setup, that's the same, but in reverse. So again, the plus button to make the video wall, the order it's in, the name, the default receiver. So again, the receiver that you're going to look at when configuring it. Again, these can be changed. You can do it to any receiver. And then the display resolution. Display resolution is the actual outside frame, so the maximum frame of the whole TV. And then you choose your video wall arrangement. So you can see there's a 20 or 18 or so there, but there's another 8 or 9 hidden below there. So you've got 27, as we can see there. And then you choose one, and then you simply do the reverse of what we did before. Rather than dragging and dropping the receivers, you drag and drop the transmitters that are all listed at the bottom here, and you drag and drop them to the position on the multi-view that you want each to go. Excuse me. Then you hit execute, and you can check it on your screen, and then you save. And again, once you save, that will then appear in the monitor and control section, and you can recall via telnet commands using a third-party control system.
Fantastic. And then the same, that's just an example of picture in picture.
Yeah, so you've got yeah, so you've got the 27. There is one that is like 16 screens and one that's like 27 or something, different screens. It's as I say, at this point, I've not had anybody using the system that says, I haven't got the multi-view I want. If you come across that, let me know.
Good stuff. I'm aware that we're very, very short on time, so if we don't mind, we'll quickly just summarize here. Obviously, the SDVoE system then is the highest bandwidth, so overall, the best image quality, the lowest latency with the fastest switching time, as Kev discussed there. And also, as I say, then you see at the bottom there, the peak signal to noise ratio. Again, the highest picture quality of all of our AV over IP systems.
You can think about that peak signal to noise ratio in an IT network as being, how many packets are lost? Is any information here lost? And at 100 dB, it is basically utterly lossless. There is not a packet of information lost in the system. So it is incredible. I mean, the things that we can do with this, once you start playing with this SDVoE system and start using it, the things we can do with it and how incredibly great the picture quality is, the switching time, the scaling, the multi-view, all of these things are things that, 5 years ago or so, we would be dreamed to be able to do with video and audio for this level of cost. The ability to do the things that the SDVoE can do at the price point it comes in is phenomenal. It's absolutely stunning.
And just looking then, so the 1 gig system we spoke about originally is much more straight down the middle. It's a good picture quality, it has good latency, and it has good peak signal to noise ratio. So again, the 1 gig AV over IP system sits sort of right in the middle. And then soon to come out, we have our HEVC system, which is high efficiency video codec, I believe, a lower bandwidth system, but it does have, you can see there, much higher latency, lower picture quality overall, but it uses much less bandwidth. So again, we'll soon have 3 different AV over IP systems to suit different applications.
Indeed.
So just to summarize really then, we will just quickly go over, because I know we are right near the end of our session, so thanks again for joining us. The SDVoE system, as we've discussed today, flexibility and scalability, add more transmitters, add more receivers, make the benefits of the high bandwidth for the overall highest image quality, the low latency as we've discussed, and also the incredibly fast switching time when you have the scaler enabled. You've got the easy to use controller, the SDV CS8, and all of those features we discussed, multi-view, picture-in-picture, video wall, all of those great features. And again, this whole series is available with either fiber models or CAT models. Of course, these could be used in many applications, but we've listed a few: high-end residential, pro AV market, medical market, military, lots of applications, all due to the benefits we've discussed today. Again, just summarizing, 1 gig versus 10 gig. I think we've covered that already, but again, very good points. And I think that brings us, look at that, 11:01, sorry, in Germany, 11:01. I'll hand back over to Manuel, but from me and Kev, thank you very much for joining us. Any questions, do feel free to ask. Back to you, Manuel.
Indeed.
Thanks, Kev. Thanks, Dan, for all the nice informations and explain us your really nice system. So I changed back to Deutsch. Ja, auch von unserer Seite vielen Dank für das Zuhören und das Interesse. Im Laufe der Session sind auch wirklich noch einige Personen mit dazugekommen, was uns sehr freut. Natürlich stehen wir und CYP jetzt dann zur Seite, wenn es einfach heißt, zur Planung bzw. zum Konzept des richtigen Systems auszuwählen. Und da haben wir einfach schon dementsprechende Hintergrundinformationen, dass wir zusammen mit Ihnen das System planen. Grundsätzlich verliere ich jetzt keine Worte mehr, sage vielen Dank fürs Zuhören. Bei Fragen jederzeit an uns wenden und wünsche allen einen schönen Tag und bis die Tage. Ciao.